Hey everybody, welcome back. This is Mr. Longo again, and we are going to continue solving trig equations. So for these guys right here, the level of difficulty might be just a little bit higher. So we're going to just kind of hop at it right now and talk about the first example where we have cotangent theta cosecant theta is equal to 2 cotangent theta. So for this particular example, since we have multiple cotangents, the best idea would be to move this over to the other side first. So we have cotangent theta, cosecant theta, minus 2 cotangent theta is now equal to 0. And the reason we wanted to do that is so we can factor out cotangent theta. So we have cotangent of theta times, now we have cosecant theta minus 2, that's equal to 0. Now that we have factored out, just like any other factoring problem, once you factor, you can set each individual term equal to 0. So we have cotangent of theta equals 0, and we also have cosecant of theta minus 2 equal to 0. And from there, we're just going to solve. So cotangent of theta is equal to 0. So you have to think about that. That is a reciprocal, so that's when tangent of theta is equal to something that's undefined. And remember, tangent is the same as sine over cosine, so it's when cosine is 1 and sine is 0. So there's multiple ways to think about that. So we have cosine of theta over sine of theta is equal to 0 for cotangent, and we have the sine of theta over the cosine of theta, that's equal to an undefined thing because that's when it's 1 over 0. So there's a lot of different things to think about. However you want to think about that, you need to know that the cotangent of 0 takes place when sine over here is 1, which means we are at the top of our circle at 90 degrees. Okay, so our first answer is 90 degrees. But don't worry, we've got to play with that. Next one, we have cosecant minus 2, which means cosecant of theta is equal to 2. And remember, this is a reciprocal. So cosecant is the reciprocal of sine, so that's when sine is equal to 1/2. So the sine of theta equals 1/2 occurs when theta is equal to 30 degrees. So our other answer is at 30 degrees. So we have 90 and 30. So now we have to go back and look at our set of numbers we are allowed to use, and it's for all real numbers. So you need to think about other locations that the cotangent is equal to 0, or when sine is undefined. So cotangent is 0 when sine, like we said, is 0. I'm sorry, when sine is 1. So it's also going to be the case down here, because when we divide by 0, that's going to give us undefined for tangent, and 0 over a negative 1 is still 0. So that would be 270 degrees. And it's also negative 90 degrees if you want to think about it that way. Now, the other one is our 30 degrees here. This is sine. Now, sine is positive in quadrant 1 and quadrant 2. So our other possible answer would be 150 degrees, because that's 30 degrees away from half circle is 180. So all of these have different potential answers. So we have 90 degrees, and that's here, and it repeats itself every 180 degrees. So we have plus 180k. We have 30 degrees, but that repeats itself every 360 degrees. So we have to add 360k. And then the last one we had was 150 degrees. And that will repeat every 360k. So that is our answer, because you must take into consideration that all real numbers means we have a general answer, that 30 degrees is one of them, and 390 degrees is another one. And that's just going to keep on repeating over and over and over. The cotangent of 90 is 0. The cotangent of 450 is 0. The cotangent of negative 270, it's got to be everything. So that's where the plus 180k and the 360k come into place. Okay? So that's our first example. Our next example, I'm going to just tell you to pause the video and give it a shot on your own. And remember, you are going from negative 180 to positive 180. And let's see what that does for you. So see if you can answer this question. Click play when you're ready to go over it. So the first one with this is to factor out your GCF of cosine theta, which will leave you with 2 cosine theta plus 1. And those are both equal to 0. So again, we split. Cosine theta is equal to 0, which means theta is equal to, now that's when x is that's when x is 0, so that would be at 90 degrees. The other one we have is 2 cosine theta plus 1 equals 0. That means 2 cosine of theta is equal to a negative 1. That means cosine of theta is equal to a negative 1/2. So remember, when x is negative 1/2, you are at 120 degrees. So theta is equal to 120 degrees. Now again, you can use your calculator to do that, but it's all from the unit circle. So if you know the unit circle and have quadrant 1 memorized, you won't need to type those in the calculator. But if you needed to, no big deal. Go use it. So the first one we had is 90 degrees. So now we need to think about where else is cosine equal to 0. Well, if x is cosine, here's 0, here's another one. So we could also be down there. For we have 120 degrees. Cosine is negative 1/2 on this side. It's when x is negative. So we also have another one right here. So those coordinates would be 120 degrees and would also be 240 degrees, because remember, this is a 60-degree reference angle, so it's 60 more degrees right there. And of course we have our 90 and 270. Okay, but now we have to talk about our range. This is only good from negative 180 to positive 180. So we have to adjust a few of these numbers. So this is the same as negative 90, and this is the same of negative 120 degrees. So our answers for this, theta is equal to plus or minus 90 and plus or minus 120 degrees. Okay? So that's that. And yes, you can list all 4 out separately if you want to. Whatever works best for you works fine for me. Last example here. This is a factoring problem. So the first thing you're going to have to do is factor, and then see if you can solve this guy on your own. Give it a shot. Like I said, the first thing we had to do is factor. So the first thing is we're going to have to ask ourselves, you know, what multiplies 2 and all of that when you are doing this in your head. Or if you want, you could do the splitting the middle term. If you remember how to split the middle term, you would multiply the first and last one together. And what you were trying to do is think about what multiplies to 4 sine squared theta, but adds to a negative 5 sine x. And of course, however you did it, you should have factored to 2 sine x minus 1 and sine x minus 2. Again, the point of this video is not to go back and reteach you how to factor. You have to know how to factor at all times. So then, we're going to set 2 sine x minus 1 equal to 0, And we are also going to set sine x minus 2 equal to 0. And just solve. So we add 1 to both sides, so 2 sine x is equal to 1. So sine x is equal to 1/2. So we have to ask ourselves, when is sine equal to 1/2? Well, you could use your calculator and just type it in. Or we can say that x is equal to 1/2 at pi over 6. Now, I hope you said pi over 6 and you didn't say 30 degrees, because we have an x value, so we have to remember we are in radians. So that's our first answer. And our second answer, we have sine of x is equal to 2, which means x in this case is not possible or undefined. Remember, sine is opposite over hypotenuse, so sine is always a fraction. At most, it's 1. So sine is never going to be equal to 2, so that guy is not even possible. So now let's go think about our circle. Our first answer that we had was pi over 6. So now we have to ask ourselves, in this case, it's sine is positive. Sine is positive when y is positive. So the other quadrant that y is positive would be quadrant 2. So we just need a pi over 6 reference angle from pi, and that would give us 5 pi over 6. And again, we can't do sine of x is equal to 2. So our two answers, x is equal to pi over 6 and 5 pi over 6. Okay, notice there was no plus 2 pi k or anything like that. That's only when it's all real numbers. So make sure you guys keep that in mind. Both of those fit between 0 and 2 pi. So for that, we're good to go. This is Longo and I'm out. See you, bye.